Today, we will be solving some practice problems regarding derivatives of algebraic functions, which means there would be no trigonometric identities nor any exponential functions. For our first problem, y would be equal to 2x cubed minus 7x plus 1. Just a recall, the most common formula in derivatives would be the power rule. The derivative of u to the power of n would be equal to n multiplied by u to the power of n minus 1. In some books, the variables here change, but the formula is still completely the same. So by this one, taking the derivative, y prime would be equal to, let's start with our first part, 2x cubed. In our case, for our formula, it would be 2 multiplied by 3 would be equal to 6 of x. And 3 minus 1 according to the formula in here would be equal to 2. So it would be 6x squared, your derivative regarding that, minus the derivative of 7 of x. You can think of this as x to the power of 1 if there is no any given. So in our case, 7 multiplied by 1 would be 7. And 1 minus 1 would be equal to 0. So this would be cancelled out and you are left with just 7. And the derivative of 1 here, another formula of this would be the derivative of any constant would be equal to 0, wherein constant here means any number like 1, 2, 3, 4, 5, 6, 7, and so on. So in our case, 1 here is a pure constant, which is equal to 0 on its derivative. And now, your derivative regarding this problem would be equal to 6x squared minus 7. Moving on to our second problem, y equal to x squared minus 2x to the power of 4 minus 3x to the power of 5th. This is purely power rule again. Y prime now here would be equal to, taking the derivative of x squared, it is advisable that you would take the derivative of each part here, starting with x squared, according to the formula again, wherein u here is equal to x, and n here would be equal to 2. By the formula, it would be equal to 2x. 2 minus 1 would be 1, but it is not necessary to put 1 here. Just put 2x. Minus, since it is a negative sign, the derivative of 2x to the power of 4 would be equal to 4 multiplied by 2 would be equal to 8x. 4 minus 1 would be equal to 3. So it would be x cubed. The derivative of 3x to the power of 5th would be equal to 3 times 5 would be equal to 15x. 5 minus 1 would be equal to 4. And this would be your derivative regarding our second problem. For our third problem, it would be y equal to 5 minus 4x plus 7x cubed minus x to the power of 5th. In our case, take the derivative of each term again, starting with 5. Y prime here would be equal to the derivative of 5, which is a constant again, would always be equal to 0, minus the derivative of 4x. Once again, it is equal to 1. 4 multiplied by 1 would be 4x. 1 minus 1 would be 0, so it would be x to the power of 0, which is equal to 1, so it would be simply 4. Plus the derivative of 7x cubed would be equal to 7 times 3 would be 21. 3 minus 1 would be 2. Minus the derivative of x to the power of 5th would be equal to, we can put this as coefficient of 1 if there is no number aside it. 5 multiplied by 1 would be equal to 5. X. 5 minus 1 would be 4. Simplifying this, your final answer would be equal to negative 5x to the power of 4 plus 21x squared minus 4. I had just rearranged this one. So this would be your derivative answer. Fourth problem would be y equal to x to the power of 6 plus x cubed plus 5x minus 8. Once again, take the derivative term by term in order to not be overwhelmed by it. Y prime right here, again, the derivative of x to the power of 6, it would be equal to 6x to the power of 5th plus derivative of x cubed would be equal to 3x squared plus derivative of 5x would be equal to 5, and the derivative of 8, which is a constant, would be equal to 0. What I mean here by a constant would be a pure number wherein it is not bounded by a variable such as x or y. It is just a number by itself. And this would be your derivative regarding our fourth problem. Fifth problem would be y equal to 3x to the power of negative 1 minus 4x to the power of negative 2. Now in our case here, it would be best to take the derivative term by term again, starting with 3x to the power of negative 1. You can see here, we have an exponent of negative. So what we're going to do here again would be to simply use our power rule. Would be to 3 multiplied by 1 would be equal to negative 3. X 1 minus 1 would be equal to negative 2. Because once again, according to our formula, subtract the exponent by 1 whenever you're taking a derivative, minus the derivative of 4x to the power of negative 2. Let's just put a parenthesis there in order to represent it. 4 multiplied by negative 2 would be equal to negative 8x. Negative 2 minus 1 would be equal to negative 3. And by simplifying this, it would be equal to negative 3x to the power of negative 2. And we have a negative sign on both sides here, which would be equal to a positive 8x to the power of negative 3. Or if you would want to get the more simpler form here, it would be equal to negative 3 over x to the power of 2 plus 8 over x to the power of 3. So either way, it would be either this one or this one as your final answer regarding on your preferences. Next problem would be y equal to 5x to the power of negative 2 plus x to the power of negative 3. The derivative of 5x to the power of negative 2, 5 multiplied by negative 2 would be equal to negative 10x. Negative 2 minus 1 would be equal to negative 3 plus, we can put this as 1x to the power of negative 3. Multiplying 1 and negative 3, it would result in negative 3x. Negative 3 minus 1 would be equal to negative 4. For your final answer, it would be equal to negative 10x to the power of negative 3 minus, since it is negative and it is positive, multiplying that, it would result in a negative number, 3x to the power of negative 4. You can put this in a fraction form, but I will just leave this as it is as your answer regarding to our problem in here. Y equal to 3 over x minus 5 over x squared. Whenever we are dealing with something like this and our x here or our variable is at the very bottom, it would be best to put this into our numerator. And by doing that, the number of the exponent in our variable here would, whenever we are dealing with a problem like this, we would want our variable x here to be on the numerator side in order to use this power formula. And by doing that, the sign on the exponent on our variable would be reversed. So it would be resulting in a 3x. Since it is power of 1, it would be power of negative 1 minus x squared again, putting in on the numerator, it would result in a negative exponent, which would result in 5x to the power of negative 2. If you can see here, it is the same step on what we did on converting this one into a fraction, but this time it is just in reverse. So it is best to know how it works. And now that we have this, it is just a repetition of our two problems earlier. Taking the derivative of this one, 3 multiplied by negative 1 would be equal to negative 3x. Negative 1 minus 1 would result in negative 2 minus, let's put a parenthesis which would represent the derivative of this. 5 multiplied by negative 2 would be equal to negative 10x. Negative 2 minus 1 would be equal to negative 3. We have a negative and negative here, which would result in a positive sign. And if you want to reconvert it into the fraction form, since this is negative, it would be positive, which would result in 3 over x squared. It is now a positive sign, plus 10 over x to the power of 3. Y equal to 1 over v squared minus 2 over v to the power of 4. And whenever you are dealing with another variable that is not x, just treat this as x because it is just a variable once again. So in our case again, we can put our variables at the top, but by doing that, our exponent's sign here would be reversed, making this y equal to 1 multiplied by v to the power of negative 2 minus 2 multiplied by v to the power of negative 4. Taking the derivative of this, y prime would be equal to 1 multiplied by negative 2 would be equal to negative 2 v. Subtract this by 1, it would be negative 3 minus 2 multiplied by this one would be negative 8 v. Subtract it by 1, it would result in negative 5. And so your final answer here would be equal to negative 2v to the power of negative 3 plus 8v to the power of negative 5. If you want again, convert it to their fraction form, which would be equal to negative 2 over v to the power of 3 plus 8 over v to the power of 5. W would be equal to 1 over 6 plus 2y over 5 minus y squared over 3. Now this is a new type of problem again. In our case, we have, instead of y, we have a w. But once again, as I said, it is just a placeholder for a variable. And for this y, we will just treat this as x again. So taking the derivative, it would be now w prime. For this one, the derivative of 1 over 6, you can see here, it is once again just a coefficient or a pure number because there is no variable such as x or y. So it would be equal to 0 plus 2y over 5. We can actually rewrite this as 2 over 5 of y. You can treat this again as a coefficient such as 3y or something. And taking the derivative of 2 over 5 over y, remember we have an exponent of 1 here. 1 multiplied by 2 over 5 would be equal to 2 over 5. And 1 minus 1 would be equal to 0. And y to the power of 0 would be 1. So you would be left with 2 over 5 as your derivative regarding this one. Minus y squared over 3. You can put this again as 1 over 3 multiplied by y squared. This is just another form of this one. And by this again, 1/3 multiplied by 2 would be equal to 2/3. y, and 2 minus 1 would be equal to 1, or we can just put this as 2/3 of y. For your final answer, just simplify all variables here, or any unnecessary things such as 0, which would be equal to 2/3, or I mean negative 2/3 of y plus 2 over 5. W equal to 2/3 minus y squared over 5 plus 4y cubed over 5. Once again, this is a similar problem to this first one. W prime now would be equal to the derivative of 2/3, which is again a coefficient, or a constant, I mean, would be equal to 0, minus y squared over 5. We can rewrite this again as 1 over 5 y squared, and taking the derivative of this, it would be equal to 1/5 multiplied by 2 would be 2/5 y. 2 minus 1 would be equal to 1, or simply 2 over 5 multiplied by y, plus we can rewrite this as 4/5 y to the power of 3, and by that, multiply 3 by 4 over 5, which would be equal to 12 over 5 y to the power of 3 minus 1 would be equal to 2. For your final answer in here, it would be equal to negative, or I mean 12 over 5 y squared minus 2/5 of y. Y equal to x to the power of 1/2 minus 4x to the power of negative 1/2. For this, take the derivative of this one, which would be equal to 1/2 x to the power of 1/2 minus 1 would be equal to negative 1/2, minus 4 multiplied by negative 1/2 would be equal to negative 4 over 2, or negative 2. X to the power of negative 1/2 minus 1 would be equal to negative 3 over 2. Simplifying your final answer, it would be equal to 1/2 x to the power of negative 1 over 2 plus 2x to the power of negative 3 over 2. Or if you would want to rewrite this, it would be equal to 1 over 2x to the power of 1/2 plus 2 over x to the power of 3 over 2. Y equal to 2x to the power of negative 1/2 plus 4x to the power of negative 3 over 2. For this again, y prime would be equal to 2 multiplied by this one would be equal to negative 2 over 2, or negative 1 multiplied by x to the power of negative 1/2 minus 1 would be equal to negative 3 over 2 plus 4 multiplied by negative 3 over 2 would be equal to negative 12 over 2, or 6. X to the power of negative 3 over 2 minus 1 would be negative 5 over 2. And for your final answer, simplify your terms, which would be equal to negative x to the power of negative 3/2 minus 6x to the power of negative 5 over 2. X be equal to square root of t minus 1 over t. When we are dealing with especially a square root here, we would want it to be in their exponential form. just a reminder, a square root of x would be equal to x to the power of 1/2. A cube root of x would be equal to x to the power of 1/3. A fourth root of x would be equal to x to the power of 1/4. This is because x here has a default of exponent of 1 and square root has a root of 2. So by this one, we would just be rearranging it. Same as true with this 2. So in this case, square root of t, we can put this as t to the power of 1/2 minus 1/t. And now that all our terms here, wait, for this one, we would want our variable t to be on the numerator. So this would be equal to t to the power of -1. Such as this, putting that in the numerator. Now that our terms here are in their exponential form, or has an exponent now, not in the exponential form, I mean, we can now take the derivative of each. So x prime right here would be equal to 1/2 t to the power of 1/2 minus 1, which is equal to 1/2 minus 1 multiplied by -1 would be equal to -1 multiplied by t, which is simply -t. -1 minus 1 would be equal to -2. And for your final answer, it would be equal to 1/2 t to the power of 1/2 plus t to the power of -2. X be equal to 2y square root of y plus 1 over square root of y. And once again, before taking the derivative, we must first make sure that all our variables have their exponent now. For in this case, we can rewrite this as x equal to 2y multiplied by y. Since it is in a square root, it would be to the power of 1/2 plus 1 over square root of y. We can put this as y to the power of 1/2 again. And by putting it in the numerator, it would be equal to y to the power of -1/2. And for in this case, since we both have a similar variable, we can combine it. Know that y here has a default of exponent of 1, and 1 plus 1/2 would be equal to 3 over 2. So this would be 2y to the power of 3 over 2. And now by that, we can now take the derivative of each. X prime here would be equal to 2 multiplied by 3 over 2 would be equal to 6 over 2, or simply 3. Y 3/2 minus 1 would be equal to 1/2 plus 1 multiplied by this one would be equal to -1/2 of y. 1/2 minus 1 would result in -3 over 2. And for your final answer, it would be equal to 3y to the power of 1/2 minus 1/2 y to the power of 3 over 2. Y equal to 6 minus x to the power of -4 over 3. This one again, y prime would be equal to the derivative of 6, which is a constant, is 0, minus 1 multiplied by -4/3 would be equal to -4/3 x, and to the power of -4/3 minus 1 would be equal to -7 over 3. for your final answer, it would be equal to 4 over third x to the power of negative 7 over 3. But if you would want in the fraction form, it would be equal to 4 over 3x to the power of 7 over 3. Either way, this can be your answer. Y equal to 6x to the power of 1 over 3 minus x cubed. Y prime right here would be equal to 6 multiplied by 1/3 would be equal to 6 over 3, or it would be equal to 2. X 1/3 minus 1 would be equal to negative 2/3. I'm sorry for that pause right there. Minus the derivative of x cubed again. 1 multiplied by 3 would be 3x. 3 minus 1 would be equal to 2. If you want to put it into fractional form, it would be 2 over x to the power of 2/3 minus 3x squared. Y equal to 1 plus x squared multiplied by 3 minus 2x. This is another formula regarding derivatives. The derivative of uv would be equal to u multiplied by the derivative of v plus v multiplied by the derivative of u. Or the other way around, v multiplied by the derivative of u plus u multiplied by the derivative of v. But in this sense, it just says that you would multiply the original value of u by the derivative of the second variable and add it with the original variable v multiplied by the derivative of u. So it does not matter whether you had changed the order. Just important is that you multiply the original value in here by the derivative of the second variable. And by that, y prime right here, we can assign this as u and we can assign this as v. So in this case, u here would be equal to 1 plus x squared, and multiply this by the derivative of v. The derivative of 3 would be 0. The derivative of negative 2x would be equal to simply negative 2 plus v right here would be equal to 3 minus 2x and multiply it by the derivative of u now. Derivative of 1 is 1, is 0 I mean, and the derivative of x squared would be equal to 2x. Combining this, it would be negative 2 plus, minus 2x squared plus 3 multiplied by 2x would be 6x. Multiply this 2, you would have a value of negative 4x squared. And since this is addition, add the common terms here. In this case, we have an x squared variable here. So we would want to combine the coefficients. Negative 2 minus 4 would be equal to negative 6x squared. 6x, there is no other variable that has an x here. So just put this as 6x, and what's left here would be negative 2. And this would be your derivatives for this one. Y equal to x squared plus 3 multiplied by x squared minus x plus 1. This is according again to our formula. Let u here be this one and v be this one. And simplify this again. For this one, take the u, which is x squared plus 3 multiply it by the derivative of v, which is this one. Take the derivative of this, it would be 2x. Derivative of x would be simply 1. And the derivative of 1 would be equal to 0. For this one, once again, it always has a coefficient of 1 in here. So if x here would be equal to 1, 1 multiplied by 1 would be 1, and subtracted by 1, it would be 0. It would cancel and leave you with a 1, which is our variable, which is our coefficient. Plus, v here would be equal to this one. And multiply it by the derivative of u. The derivative of x squared would be 2x, and the derivative of 3, which is a constant, would be 0. Multiply these two together by FOIL method. It would be 2x cubed minus x squared plus 6x minus 3, and distribute 2x among this, which would be equal to 2x cubed minus 2x squared plus 2x. Let me just erase the formula here. And by combining our terms right here, wait, this should be plus. This should have a plus sign in order to not signify that you would multiply this to each other. Since this is addition, we would want to combine like terms here, or the one that has the same variable, such as this one. They both have x cubed, and so combine their coefficient. 2 plus 2 would be equal to 4, and copy their variable, which is x cubed. For the x squared, we have this one, and we have this one. Negative x squared minus 2x squared would be equal to negative 3x squared. Next one would be the variable of x. 6 plus 2 would be equal to 8x. And what you're left with here would be equal to negative 3. And this would be your final answer regarding the derivative of this function. F of x be equal to x squared plus 1 over x squared minus 1. So in our case now, we had a division between two terms. The formula for this would be the derivative of u over v. Wait, this should be derivative of u over v. It would be equal to v multiplied by the derivative of u minus u multiplied by the derivative of v over v squared. For this one, the order does matter in here. If you would want to reverse this one by the first, you would have a different answer. So please remember that this would be the exact formula for the derivative regarding division or fraction. So in this case, we can assign this one as u and this one be v, and by the formula, f prime of x would be equal to v multiplied by the derivative of u, which would be x squared minus 1 multiplied by the derivative of u. Derivative of x squared would be 2x. Derivative of 1 would be 0. Minus u multiplied by dv, which is x squared plus 1 multiplied by derivative of x squared would be 2x over v squared, which is this one. So it would be x squared minus 1 to the power of 2. Simplifying this, distributing 2x among this, it would be equal to 2x cubed minus 2x minus, distributing this again, it would be 2x cubed plus 2x over x squared minus 1 to the power of 2. And before combining, make sure that the negative sign here is accounted, which means to distribute it among the two terms that it has. So it would be negative 2x cubed minus 2x. So f prime of x here would be equal to, combining these two terms, 2x cubed and 2x cubed, since it is a negative here, it would result in 0. And for this, negative 2x minus negative 2 minus 2x would be equal to negative 4x over x squared minus 1 to the power of 2. And this would be your final answer.